where we are in terms of the unit logic. So we said that we can evaluate the limit of the function, which means that we can investigate if x approaching specific value, and it can be just any value, what does the function approach? And when we say the function approaches, then we mean the y value. What does y value approach as x approaches specific one? So this is what we, the context we are working in, evaluating the limit of a function. Now, yesterday we took the properties of the limits, which you actually are going to apply along with the strategies of evaluating the limits. I also want to tell you that yesterday and the day before, we were focused on investigating the graph of the function, and this would give us a clear picture about the limit, whether it exists or not. Now, today, we are mainly working with algebraic tools. But before we move on and we look into each and every strategy, I would like to ask you, what is the main condition for the limit existence? How do we know if the limit exists or not?
If both sides from the left and the right are approaching the same number.
The same what? The same what?
I said number. Like
the same number. The same number. If both sides are from both sides, the function is approaching the same number, then the limit exists. Okay, good. So let's go on. Let's start. Please write down the first strategy, which I already mentioned before, is evaluating the limit by direct substitution. I would like to highlight it once again. Whenever you are facing a question from the textbook, which does not tell you, because sometimes the question will ask you to use specific strategy. Sometimes it will just tell you evaluate the limit. So when it just tells you evaluate the limit, then the first thing you should think about always, without exceptions, is whether I can substitute the value of x right away or not. Okay. So in this case, as we know, all the polynomial functions are nice functions to deal with. So you can just sub in the value of x right away. So if you do that, what will be the value of this limit, please? Who would like to answer?
I can answer. It's going to be...
who is that? Again, Abdurrahman?
Yes.
No, I want something that someone else for
19.
Mohammed?
It's 19.
19, right? Okay.
Yes.
I hope that there are no issues with this part. Okay. Just remember that it does not have to be a polynomial function. It can be just any function, and still direct substitution will work. So do not underestimate this method. Always consider it first. Strategy number 2, evaluating the limits by graphing. Can you please write down the strategy? And this is the example. The limit of the function y1 over x minus 3 as x approaches 3. My question for you is, what is the type of the function that we are looking at? What's the type of this function?
Reciprocal.
It's a reciprocal function. And if you remember reciprocal function, and reciprocal function of which function? What is the original function here?
Linear.
Linear. Okay, so it's a reciprocal function, but if you remember, reciprocal is just one of the examples of a rational function, right? So rational functions is a big group of functions where reciprocal is a subset of this group. Okay, why I'm doing this now? Because we are going to work with the functions, we're going to sketch them, and all of this knowledge we gained in advanced functions will be needed. So if you need to graph quickly, right? Because you don't need to sketch quickly in order to just evaluate the limit, you will use the features of the linear function, which is x minus 3. And then you remember some of the features are exactly the same, some of the features are opposite, and so on. So if you graph this function, you will get this curve, which is broken down into two pieces by the vertical asymptote x equals 3. And since the only condition for existence of the limit is the left-sided limit should be equal to the right-sided limit, it gives you the clue how to think about it. Okay, I sketched it, and then what? And then what? I'm going to think about the left-sided limit and the right-sided limit. So I would like to ask the following question. What does the function approach when x approaches 3 from the left? What does the function approach?
Negative infinity.
Negative infinity. The next question, what does the function approach when x approaches 3 from the right?
Positive infinity.
Positive infinity. What is the conclusion? Does the limit exist or not?
Yes, it does.
It does? Okay, let's review the
No, yes, it doesn't.
existence. So why are you saying, Abdurrahman, that it doesn't? Could you explain once again? Because Noor says that it does. He says that it exists.
Okay, so it wouldn't exist because the points never actually get to 3. Both of them. So like they're both, and one's approaching. I don't know how to explain. Like I know it doesn't exist. I just can't explain it.
It's a problem. You're in trouble. If you know it but you can't explain, you're in trouble. You have to keep trying.
Is it just because,
Hey, Farida?
is it just because it's different, like the approach different things from the left side and the right side?
Exactly. Function is approaching totally different things from the left and from the right. Didn't you say, Noor?
Yes, different points.
It's not points. And moreover, I would like to say that infinity, as I told you before, is not a value. Infinity is a concept. There is no constant value behind the sign infinity. Okay, so this is another story. Actually, limit, if you remember from the definition of limit, is a constant. It's a number. Okay, so the function is not approaching even any number here. This is one thing. But the clear observation that you should have made is that it's approaching on one side the positive infinity, on the other side a negative infinity. So basically it's opposite. It's approaching opposite directions. Of course, the limit does not exist in this case because it exists only when the function approaches exactly the same value. Even, I want to tell you something, even if the function was approaching negative infinity from the right and from the left, okay, if this curve was like this, down, symmetrical,
The limit still doesn't exist.
still it wouldn't be a limit. Why? Because the infinity is not a value. Okay, let's move on.
Listen, I have a question, but I don't know if it's like correct or not.
Yeah.
I don't know even if the question I'm saying is like a good question to ask or not. So technically, like we did this by graphing, but we could also, if we solve it by substitution, it's gonna be 1/0.
Yeah, but but if you substitute and you get
Yes.
1/0,
So there.
it still doesn't mean anything.
No, it means that it's unidentified. Like there's no limit. That's what I'm saying.
No, then why are we doing all of this? I'll tell you why. Because sometimes the function, you remember, is undefined, but of course, if it's a vertical asymptote, it will be always the case. But what if it's a whole? It will be always also undefined, but still the limit will exist.
Yes, I know. And if it's 0/0, that's
Yes, if the only thing you have in the denominator is the vertical asymptote, right?
Yes.
Then the function will never have the limit there in this
Yes.
way.
It's only gonna have the limit is when like both it's 0/0.
Yeah, if to simplify this thinking, I'll just tell you, if you substituted and you got 1/0, this is not sufficient to make a conclusion. You have to rearrange the function, to graph it, you will see more tools today in order to make a conclusion. So just substituting and getting 1/0 is not considered to be a sufficient reasoning about limit existence, okay? Right, let's move on. You have only these strategies we are taking today. It's 6 strategies, and it's a must to use one of them when you are evaluating the limit. And even if you discover that it does not exist, you have to use one of the strategies. Strategy number 3, can you please write it down? By variable substitution. So evaluating the limit by variable substitution. This is the most challenging one. So I would like you to give your full attention to this point, okay? So by variable substitution. Let me remind you that we are familiar with the method of variable substitution. For example, from the last unit in advanced functions, when we were substituting, when we were introducing a new variable to solve exponential equations, if you remember. Okay, so, and generally, introducing a new variable is a method which is used in many aspects of math, okay? So here, it works differently than, of course, in exponential functions, in exponential equation solution. We are going to go through the steps right now, and the example is on the left, okay? So my first question, so that I can convince you, or you can get convinced that no other method can be used here, is, just a second, let me just copy it, and you write it down, okay? And I'll copy the other part as well, just 1 second, not to waste more time. Okay, my question is, what can you say? Do you see, first of all, the exponent in the numerator? What is the exponent?
1/3.
1/3. This is a rational exponent. Okay, how can we replace a rational exponent with a radical sign? This one. How can I?
Square.
Would be square root.
Guys, how to read it?
Cube root.
Cube root or third root? Third, fourth, and so on. Third root of x plus 8 minus 2. Okay, so on one hand, you can you might think, we have one of the methods which we'll be looking, or strategies which we'll be looking into later on, by rationalizing. And this is something which is familiar to you, right? We were doing this at the beginning of the unit. You might think, okay, there is a radical, it means automatically that I need to rationalize the expression. My question is, why this is not possible here to apply the same method of rationalizing when we were multiplying by a conjugate? So look at the expression.
Root, not the square root.
Yes. Yes, thank you, Lila. Good. So for those who didn't understand what Lila said, we used to have square root of x plus 8 minus 2. The square root, if we apply the conjugate, right, which means that we are going to square this. So squared square root is going to be cancelled, right? And this, the entire method is based on this, that the difference of squares will allow us to cancel the square root. So rationalizing will work in this unit only when you have a square root. If you have any other root, you cannot rationalize, okay? Now, why can't we use, by the way, the direct substitution?
Because the denominator.
Because
One person.
Be undefined.
It will be undefined, right, if we substitute. Okay, then it's time to think about another method. And here comes the new variable introduction. Okay, so how it will work? There are different, like around 3 aspects to think about. First of all, and if you want to take notes, take it as like tips, how to approach. Whenever you decided to use the variable substitution, then you find the expression with the radical or with a rational exponent, which is the same thing, and substitute the entire expression with a new variable. So this is the first trick. So as you can see here, right, we took the entire expression x plus 8 to the power of 1 over 3, which is the same thing as third root, and replaced it with a new variable u. Okay, so this is the first thing, like first step to think about. Step number 2, I need, if this is u and x is part of this expression, then what is x in terms of u?
U cubed. Sorry, it's going to be x plus 8. Yes, x plus 8.
This is very like you are in a hurry.
Miss, so first, can I say like what I think we should do first?
I'm ready to take your suggestions. Yes, please.
Okay, so first we're going to like cubic raise it to the power of 3, like u and x plus 8.
Raise it to the power of 3, because I want to isolate x, right? In order to express it, I want to isolate it. How to isolate it? By raising both parts of the equation to the power of 3. Why to the power of 3? How did you know?
Because 1 over 3 means root 3.
Not because of that. Because I want to cancel 1.
Yes, yeah. I'm saying because this means root 3, so when we raise it to the power of 3, it gets cancelled.
Okay, or like here, you can see that it's the power of a power. When you multiply the powers, 3 and 3 get cancelled.
Yes.
Okay, so now I am here with the expression u to the power of 3 is
equals x plus 8. So x is going to equal u cubed minus 8.
Yeah, so it's easy to solve for x. So this is the second aspect of this process. And finally, you need, because how does the substitution as a method work? You replace everything related to the old variable with a new variable. You cannot have in a new expression a combination of the old variables and new variables. Why am I saying this? Because, okay, I'm ready, going back to the function. Yes, I'm ready now to express this in terms of u and this in terms of u. But there is something else left. Here, under the limit, there is also x. So it cannot be x approaches 0 while I have u in the function. This is what the next thing to think about. So if x, in this case, approaches 0, remember it can approach anything.
Yes,
then what does y approach? And the
y
answer,
or u? U is going to approach 2.
I mean u. Yeah.
We're going to put in x with 0, and then we're going to solve. It's going to be square root of 8, which is 2. Sorry, the cubic root of 8.
Yeah, so the answer is here, right? So if I know that this is approaching 0, right, then it means that u to the power of 3 minus 8 should approach 0, right? And in which case will it approach 0? When u to the power of 3 is approaching 8. So when will it approach 8? When u is approaching 2. Do you have questions? Like, okay, what Abdurrahman said, he said, I can substitute x in this equation with 0 and then solve for u. Well, okay, but I mean, it's not, strictly speaking, we do not equate it, right? Because we say approach, we don't say that x equals.
Yes, but we also know that it's like, the difference is really small. Like, it's like 0.01.
I agree. If it makes it clearer to you, you can work with it this way in your drafts, right? And then write it properly in the part which you want me to check. Okay. So
I don't understand why it's why you approaches 2.
وانا كمان الصراحة.
Yeah, Abdurrahman, why you approaches 2?
Okay, so as we know that x is approaching 0, right?
No, let's. I think this will be enough if you just explain this part.
Okay, so so u cubed approaches 8. So if u cubed approaches 8, we have to like simplify it. Let's say we're going to simplify it. So we're going to put 8 and u cubed under a cubic root. which
Yes,
would
as if it's like this, and you then
yes, and
use
then just cubic root, and 2 times 2 times 2 equals 8, so u equals 2. And then u is approaching 2, because the difference between like approaching and equals, it's really small, like it's 0.000000001. So
Okay, good. Any other questions? Okay, so let's go back. So now we are here. We are here, okay? Let's make sure that we all understand how we arrived here. So we took the first term in the original function, and as we know, it is equal to u, the entire expression with a rational exponent. This is the one, okay? So this is u. So we replaced the entire expression with u minus 2 as is.
Miss Natalia,
Over, just a second, x. X is, as we said, we isolated it, is u to the power of 3 minus 8. So this is how we got it. And of course, under the limit sign, we have to add u approaches 2 instead of x approaching 0. Yes, Abdurrahman, the question.
no, it's just because no one gets confused. You forgot to take the 3 off the u cubed when you equated it to x plus 8. Like in the red part under when you put like put اسمها ايه؟ خلاص never mind.
But tell me where, which line in the solutions on the right? Which line?
لا. Okay, now I got confused. Yes.
Right, so this is how we like exchanged. We completed the introduction of the new variable. So this is how it looks now in terms of u. And we say that it's an equal sign, right? Because we replaced u, each part of the expression with u. And then what is going to happen next? And why actually we have done this? Because we know that you don't know yet, you're going to know it now, that u to the power of 3 minus 8 is a pattern which can be factored, okay? It's a difference of cubes, and I would like you to write it down, and whenever you are solving something where you need it, it will be provided. It's like the difference of squares somehow. I mean, it's a formula which you don't need to memorize. So how does the difference of cubes looks?
Miss, can I say?
Difference of cubes. How do you know? Abdurrahman again?
Yes. I finished all the strategies yesterday.
What?
I went through the book yesterday. Like
No, don't tell me. What I want you guys to do, it's very easy, like to derive this general formula from here. So from here to here, the denominator was factored using the difference of cubes. So Farida, can you try? Tell me, in terms of A and B, how the difference of cubes formula will look like. What is the first bracket and what is the second bracket? Farida.
So it's going to be. Oh wait, would you find that?
You just need to compare this to this.
Oh, okay. So just A.
Mm-hmm.
And then, how did you go from 8 to 2?
What do you think?
Like what we did
This can be
Cube root, right?
yes, it's going to be B.
Yeah, it's going to be just B. Hold on, Abdurrahman. Farida, the next part. How does the second bracket look like?
A squared.
Yeah, and the last term.
The last term, which is squared, is going to be B squared.
Absolutely. Yes.
Miss, can I say how we're gonna get the middle one?
And no, and what's the middle term, Farida? What do you think? What is 2 and u here?
In this case,
Anyone else who sees it except for Abdurrahman?
Is it 2AB?
2AB.
Is it 2ab? Look here, u and 2.
No.
It's B.
AB.
It's ab.
Miss, but it's A, so we multiply the first 2 together, but we switch the signs.
Okay, so what I want to add, since we speak about the formula, sometimes you will see also the sum of the cubes. So the difference between, you remember we had difference of squares, but we don't have difference of, sum of squares. For the cubes, we have both. So difference of cubes and sum of cubes. And as we are discussing, someone can Google the sum of cubes formula. So a to the power of 3 plus b to the power of 3. It's very similar to this one. The difference is only on the level of signs, well, negative, positive. So I'll write this as this. You will just tell me what are the signs. So what is the sign in the first bracket?
Plus.
Plus. What about the second bracket?
That's like minus.
Mm-hmm.
This, didn't we take this last in advanced functions?
And then minus again.
No, we didn't.
Frankly, because it is in the advanced functions, I don't remember. The other group told me no, because it was a very small. It's a very small part.
I remember there were like 2 questions about this in advanced functions.
Probably I gave it as homework or something, but I was not focused on it. So, anyways, it's easy because it's formulas. There is nothing to think about here, right? Okay, so this is for your reference. You will just a second. So you might use them, both of them, when you deal with the strategy number 3. Okay. Yes, Noor, your question.
Is the square like b squared? Is it inside the bracket or outside the bracket?
Inside.
Okay.
Yeah.
بس
Everything
no
is
no 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 ثانية
in both cases. It's inside. Okay. All right, guys. So let's move on. So in this question, right? So now we know the denominator has been factored using the difference of cubes. And then once it has been factored, look at it. Tell me what has happened.
Now we have u minus 2 up and u minus 2 down, so we're going to cancel them with each other.
So this
We're going to make a whole.
This allows us to cancel our obstacle, right? Because if I substitute 2 here, it will be 2 minus 2, which is 0. So finally, we can cancel it out. So we'll be left with this one. And once we have a fraction like this, there is no issue, or like there is no problem. I can just substitute u with 2 and then do the calculations to get 1/12.
Can be 4 plus 4 plus 4.
Yeah. Okay. So this is the method. It takes some time to practice. Okay. So, but it's fine. I mean, it's doable. Okay. So let's move on. We will complete all the strategies. The rest are easy. Then we will take a break, and then we will take practice questions, as many as we can, where we will practice how to apply the strategies. Okay. Next strategy, please. Strategy number 4 is evaluating the limit by factoring. And I hope that the word factoring is so familiar to you that you will not have any issues with applying the strategy. So let's do the example here. And my question is, why can't I use the direct substitution right away?
Yes, because it's going to be.
Abdallah, why can't you use the direct substitution in this question? Okay. Asil.
She just left us.
Ali.
Yes.
Mm-hmm. So why can't I use the direct substitution in this case?
Use what?
Why can't I use the direct substitution in this limit?
Can't use if you substitute 3 minus 8 will be 0. We can't.
Exactly. Good. Very good. So we can't do that. So now we can consider factoring. Of course, I cannot factor the linear expression, which is in the denominator. So, but I can factor the simple trinomial. Not Abdurrahman. So, guys, now how can you factor the? I mean, you have done it at home, right? And so
Miss,
who can factor?
It's going to be x and x.
Noor, can you do it? Noor, Gennady.
I was gonna ask what is the name of this method?
Where is what?
What is the name of the
Factoring, you know,
method?
factoring.
Where is the?
He's asking the name of the strategy.
The strategies by factoring. Okay, Noor Fahmi, can you factor?
It's gonna be x minus 1
Is it
and then x plus 3.
I don't think so.
It's x minus 3 and x plus 1.
Oh, yes.
The opposite, yes. Minus 3, x plus 1. Now, Noor Fahmi, why? What happened here? What can we apply?
You can cancel out the x minus 3 on the numerator and denominator.
And after that?
It will be x plus 1.
Yeah.
And you can substitute instead of x 3.
Right. So what will be the value of this limit?
4.
4. Good. That's it. You see, easy. Factoring is easy. Okay. Next strategy. By rationalizing. So
Yes, I have it.
number 5. So evaluating the limit by rationalizing. Write it down and write down this example. What is the question?
Can we go back?
Back?
Yes.
Okay, just a second. I'll take this one there. Okay.
So, Miss, here, like in the first equation, if we substitute the 3 like in both, isn't it going to be 0 over 0 and not 1 over 0? So it's not undefined, it's undetermined. So like it could be any number or not, any limit.
If we substitute here, x with 3, we'll get negative 3 over, sorry, it will be something over 0.
It's going to be 0 over 0.
Why? Maybe 0 over 0. 0 over 0 is also something that we...
It's undetermined.
Undetermined, exactly. So, but actually it's a whole, right? If you look at it from a different perspective, you know that it's a whole. So the function is undefined at 3, but limit exists.
Yes.
It's a linear function with a whole. Okay. But I mean, why you ask this question? I can only repeat the other thing. As you can see here, substituting 3 right away and saying, oh, limit does not exist because of this. As you can see, this is not true, right?
Yes, 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 I know.
Okay, evaluating the limit which contains square root. So, Mohammed Tolba, what do you think we can do here?
We can try and get rid of the square root sign.
Yeah, by which method? What are we going to do?
When we square it.
We cannot square it because it's not an equation.
Getting the
you understand the point. Actually, it's good that you said it. You understand the point that, for example, if I have x equals 2, I'll take the simplest thing, right? And then I square it. I am not changing anything. It's true that x squared is 4, okay? I'm not changing the equation. But if I take an expression, x plus 3, which is outside the equation, and I just square it, I'm changing the whole thing. You understand? That it becomes a quadratic function. So I'm dealing with something else. So I cannot square anything unless it's an equation with the 2 sides, because then you will change the function. So no, you cannot square it.
Yes, we're going to multiply by the conjugate.
Abdurrahman, you are banned to talk unless I ask you to respond.
Okay.
Okay, so we are going to multiply by a conjugate. So, Mohammed, do you remember what's conjugate?
Yes.
So tell me what is the expression which I'm going to multiply this one by?
So in the numerator, we have the square root x plus 1.
And
then it'll be plus 1.
Yeah. And what about the
it's the same.
It's the same. So I want to, Mohammed, to complete my explanation. Do you see that now? What have I done? I have multiplied the expression by this expression. But did I change the expression, the initial one? No. Why didn't I change it? How can you prove that I did not change the initial expression? Or if not Mohammed, who can prove that I did not change the initial function or the initial expression?
Like, do you mean like
Is anyone?
Farid, what are you saying?
I was saying, yani, are you asking any why we can't change the initial?
No, I'm asking because I had this discussion with Mohammed about squaring. He said, let's square it. And I said, you cannot square because it's not an equation. So by squaring anything, you change it. It becomes something else. But by multiplying it by this, I did not change it. So I'm asking, how can you prove that I did not change it? Anybody? Except
Anybody?
Except for it's a piece of a discrimination in my lesson today for a change. No? Guys, it's okay, Abdurrahman?
This because we multiplied the we multiplied the top and the bottom are the same thing, so we didn't actually change the equation. We just changed the.
Okay, but this is not what I'm. Yes, because we know that the fraction. If you want to keep the fraction as is, you can multiply.
Yes.
Same thing, numerator, denominator. Okay, but I thought that it will be more where I was heading. I thought it will be straightforward.
Because we didn't multiply the numerator only.
What's the value of actually of this quotient?
1.
Is 1.
Yeah, it's as if we multiplied it by 1. Yes, exactly.
Multiplied by 1, exactly. So, okay, that was my point. So I did not change anything because in fact, I multiplied the initial expression by 1. And when I multiply by 1, I don't change anything. Okay. Let's move on. So when I apply when we have applied the conjugate, Mina will tell me what will be the numerator now.
It will be x plus 1 minus 1.
Okay, so it will be x plus 1 minus 1. And Mina, what is the denominator?
It will be x times root x plus 1. And
you
then
must always be accurate. Which root? Square root.
Square root. Yeah.
So because they are all different, the roots, right?
Plus, yeah.
Good. Next step.
Which we will cancel out the one with
Habiba, next step.
Can I see the board again? Okay, so you're gonna cancel out the x's and then the 1 and the minus 1.
But before I cancel x's, I have to do something like the way it looks now. I don't have the right to cancel x because x plus something.
Oh, we'd cancel the 1 and the minus 1.
So you have to cancel them first in order to have the legal right to cancel x. Okay.
And you cancel the x's.
Yeah. So what will be the final expression for the limit?
1 over square root x plus 1 plus 1.
Square root x plus 1 plus 1. And Habiba, what are we going to do next?
Sub in 0.
Yeah. So now we don't have this issue. If we sub in 0 here, what will it be equal to?
It's going to be 1 plus.
They're not allowed to talk unless I asked you to answer. Okay, Habiba. So what is the square root going to be?
Miss, you want the final answer?
Yeah.
It's 1 over 2.
Yeah, 1 over 2. Good. And I think it was the one before. Yeah. So last strategy. Congratulations. Strategy number 6, by using a table of values. Okay, I want to make it clear at this point that one question might be solved using different strategies, right? However, I am trying to teach you to use the most efficient and which means the shortest way of solving it, right? For example, in this question, we have a limit of x squared minus 1 over x minus 1. And we are going to discuss how to solve it by using a table of values. However, as you can see, using a table of values is a very long method. What is a shorter way to do it? Look at it and tell me what other method do you see or strategy which you can apply here in order to solve, to evaluate this limit?
Factoring.
Factoring. Who said this?
Mina.
Mina. So how can you factor this expression?
Different squares.
Yes. So tell me how it look like when you factor it.
Okay. So in the numerator, x plus 1, x minus 1.
So x minus 1, x plus 1. Denominator.
Yes, and then denominator x minus 1.
Okay.
And then we cancel out the x minus 1 with the x minus 1 to be to remain x plus 1, and then x equals 2.
X equals 2? No, x does not equal 2. X is 1.
We will sub in 1, and then it will be 2.
So the limit of the value of limit is 2.
2.
See,
Yes.
very quickly. And actually, yes, this is true because this is the final answer down here. Okay, so whenever you have an opportunity to choose the strategy, you will be going for the one which is the shortest and the easiest one.
So Natalia, I have a question.
Yeah.
For the table of values, wouldn't it also be easier to just take the 0.999 and 1.001 and see what they get and is going to be the closest number?
Abdurrahman, I'm definitely going to discuss the table now. Okay, just be patient.
Natalia,
Yeah.
I don't understand the method of the table of values.
Did I even start speaking about it? I didn't, right? So I'm going to talk about it now. My point was only to tell you that, okay, we are going to solve this limit or to evaluate this limit using the table of values, but it does not mean that this is the only way. Mina has just showed us that you can solve it using factoring as well. Okay, so but if the question is asking you, sometimes the question will be imposing the method. Okay, so in this case, for example, we will look into the evaluating the limit with the help of table of values. How it works? It works exactly the same way as when we were exploring the end behaviors of the function before we were graphing it. So if you understood it well back then you will not have any issues here. So how it works? We check what is the limit, investigate, like what is x approaching in the question. So x approaches 1 according to the question, right? So that means it's like with the vertical asymptote, you remember, if the vertical asymptote is x equals 1, we start checking, okay, taking the values from the left and from the right, then subbing them into the equation of the function and getting the output, and then analyzing. So what happens to the output, which is the value of the function, or y, as we come to 1 from the left. Okay, so this is exactly the same idea. If you think about the values which are close to 1 but are from the left, getting closer and closer, it's basically enough to take only 2 values. There are more here so that to make it even more clear. So if I take 0.9, 0.99, 0.999, I'm getting closer and closer to 1 from the left. And if I sub in these values into the function, my output will be 1.9, 1.99, 1.999. So Noor Fahmi, you can see the pattern, right? Which value is the function approaching?
2.
2. And then you remember that function value is the same thing as y value. And the y-axis is the vertical axis. That's why we can see whether it's approaching it from above or from below. So in this case, why we see that it's approaching 2 from below? Farida, why do we say that we're approaching 2 from below in this case? Who knows?
Because it's on the left side.
Because it's on the left side. So if it's on the left side, then it's from below.
It's below.
Oh, yeah,
two.
because it's approaching 2 on the y-axis, right? So it's coming from below because it's.
Yeah, because on the y-axis, the lower the number is, the smaller it is, right? The higher the number is, the larger it is, right? So that's why, since this is less than 2, so it's approaching 2 from below. In the same way, we are doing the calculations on the right. So if we want to investigate what happens when we come to 1, close to 1 from the right, we take values close and closer. Here you should look from right to left. 2, then 1.5, then 1.1, then 1.01, then 1.001. So this way I'm getting closer and closer to 1. You don't have to do 5 values for sure. 2 values will be more than enough. For example, 1.01 and 1.001 show already the pattern. 2.01, 2.001. So again, we're approaching 2, and since 2.001 and 2.01 are higher than 2, then we say that it approaches it from above. However, from above or from below makes a difference when it comes to graphing, because we want to know where to graph the piece of the curve. For limits, it's not important. For limits, it's not important whether it's approaching from above or from below. What matters is that we see that the function approaches exact same value for y, which is 2. So we make, based on these calculations, we made the conclusion that the limit is 2. Do you still have questions? Noor, Fahmi, you're telling me you don't understand how it works.
No.
Okay, fine. Okay, guys, so we are done with the strategies. Right now, you are going to take 5 minutes break, and we will start practicing at 10:45.
Mister, I have a question.
Yeah.
Yeah, I'm not sure what this table helps me to know when the limit is 2.
Could you repeat? This negative or what?
How does this table help me know that the limit is 2?
Which means that I have to explain it from the beginning.
لا مش هندخل because there's 3 and you said that it doesn't matter to the limit if it's coming from above or from right.
From above or from below, it doesn't matter. But do you see in these calculations, if you take these values from the left, for example, 0.9, 0.99, if you just input them here, your output is going to be something very close to 2. Do you see that? That those values are very close to 2.
Oh, yes.
And then you take one from the right, which is these values. Again, you take them and you just input into the formula. The y will be like this, which is also very close to 2. Yes. So you are only expected to observe the pattern that it gets close to 2 whenever I'm coming close to 1 from the left and from the right.
Yes, thank you.
Okay. So 10:45, we're going to start practicing and applying these strategies.
Miss Natalia, can you get us back to the presentation?